Hello learners, we meet here on the Black Slides online learning platform where we meet for lessons in Msce science subjects, namely physics, chemistry, biology, and mathematics. So we meet now for Form 3 chemistry topic, which is called the experimental techniques, and in particular we are looking at a subtopic which is called the safe ways of disposing chemical waste. So this happens to be lesson number 2 of the topic. In lesson number 1, we looked at the definition of a chemical waste. We looked at the definition of a chemical waste. We defined a chemical waste as any unwanted chemical product or chemical material, which can also include expired chemicals which are no longer usable in any subsequent experiments or activities. But the definition is also extended to include any other material other than chemicals, such as waste papers, rubber materials, plastic materials, broken glassware, and others. All right, so in addition to that, we also looked at ways of disposing or methods of disposing wastes, laboratory wastes, such as use of bins, use of designated containers, special containers, incinerations, use of recycling, and other methods. In this lesson today, we are going to focus on the 3 types of waste based on their physical nature or physical characteristics, namely solid waste, liquid waste, and gaseous waste. So we are going to look at safe ways of disposing of each type of waste. First, we look at how we can safely dispose solid waste, and later we look at how can we safely dispose liquid waste, and then lastly, how do we handle chemical reactions that produce gases. Let me ask you to watch the video up to the end, and also pay specific attention to key terms as they come. Remember that your examiners will examine you on your understanding of the key concepts and how you apply them in solving problems or giving explanations. My name, once again, is Mr. Pochilola, your teacher. In case you have questions or queries, simply present your queries on these numbers shown on the screen, or you can simply drop them in the comment section on this YouTube channel. So welcome to steps to follow when disposing solid waste. First, maybe it would be appropriate to define a solid waste. What is a solid waste? By definition, a solid is a form of matter or state of matter in which the particles are in fixed positions and they are arranged in a regular pattern. A solid is any state of matter in which the particles in it are in fixed positions and they are arranged in a regular pattern, such that the particles are not free to flow, all right, like they do in air and water or gases and water. So the particles in such wastes are tightly compacted together, falling in the properties of solids as you know them. All right, so that's a solid, by the way. All right, so you learned in Form 1 or Form 3 that particles in a solid are compacted like that, such that there are no conceivable spaces between the particles. So there are some weights that are generated in the lab such that they are in solid form. They are in solid form, meaning that their particles are not so free to flow as they do in water and gases. So that's the definition basically of solid weights. So solid weights are just weights in solid form, if we put it simply like that. Very, very important. All right. So when disposing such weights, we need to follow certain guidelines or certain steps. All right, for us to successfully dispose or get rid of such weights, we need to follow certain guidelines or certain steps. All right, so when you notice that you have weights are generated in your lab, first you need to have a special container which is labeled solid waste. All right, so you must have a container that is labeled solid waste. So all solid waste will be deposited into it. So we are saying store. All right, so waste that are in solid form should be stored in a well-sealed container labeled solid waste. All right, so first the container should be one that can be sealed. Okay, once the wastes are deposited into it, are thrown into it, it can be sealed. It must have a lid on top. That means it must have a lid on top. All right, can you think why the container needs to be sealed when wastes are deposited into it? All right, that's an examination part. Okay, you may be asked to explain why a waste container should be sealed. All right, okay, and why should the waste container be labeled solid waste? Why is it important to label such containers? All right, in case you have generated, in the course of your experiment, you have generated solid wastes that are reactive. All right, reactive wastes, solid wastes include metals like sodium metal or lithium metal. Those are highly reactive metals. You may have dropped a piece of sodium metal, for example, in water. You see a very violent and vigorous chemical reaction associated with some flames, right? Flames and fumes being produced. All right, so those are reactive metals. So reactive metals, reactive solid wastes must be stored separate in separate containers. All right, so they should not be mixed with other chemicals. For example, if you mix them with water, there is going to be a violent reaction, chemical reaction. So that can cause a lot of danger to you, the user, the student, and those that are working in the laboratory. So reactive solid wastes, we are saying, should be stored in separate containers. So why separate containers? So that there are no chemical reactions, dangerous reactions taking place. All right, very harmful solid wastes must be incinerated. Remember last time we defined incineration as a method of waste disposal which involves burning. All right, so those which are harmful and difficult to handle, they should just be burnt to reduce their accumulation or to reduce their volume. Because if you don't burn them, it means they'll accumulate. They accumulate and pose a very serious danger to you and your colleagues in the laboratory. So we are saying very harmful solid wastes must be incinerated, meaning they should be burnt. So take them, transfer them to a place where they can be burnt. You don't burn them right there in the lab, no. There is a designated place where wastes are to be burnt. Less harmful solid wastes such as paper, rubber, wood should be in waste bins, should be placed. This should be placed. Should be placed. This should be placed here. Should say should be placed. Should be placed. You should place them in should place them in waste bins. In waste bins which are available in your chemical or chemistry laboratory. Then these will be collected and deposited or disposed into a rubbish pit outside the laboratory. So there are some wastes that are not harmful, but if you allow them to accumulate in the laboratory, they can pose a serious contamination. All right, the site in the lab will not be admirable. So you need to collect them and heap them into waste bins and which are placed in the laboratory. If you look around, you find that there is a bin where you have to deposit your wastes, harmless ones. All right, and later on you transfer the bin to a place where they can be dumped. We call it a rubbish pit. Usually this pit is outside your laboratory. All right, some wastes are classified as less harmful or harmless. All right, for example, paper, plastics, rubber. These, if you have the capability to do so, should be recycled into other products to produce or to reduce their accumulation. All right, so we are saying, for example, suppose you have plastic bottles. Maybe you have plastic bottles which you think are waste. All right, you can turn them into useful products, such as maybe using them as beakers. So you cut them nicely, use them as beakers, or you can, melt them and turn them into atomic models, and many products you can make. So those wastes that are less harmful or they're harmless, such as papers, plastics, and rubber, can be recycled. You can turn them into something else which can be used. So the advantage of recycling is that it will reduce their accumulation, the increase in volume of them. Very important. So we are saying these are the steps to be followed. Please make sure you know all of them so that in the exam you can give any two when required. I hope we are good on this. These are steps to follow when disposing solid waste. If you have a question, don't hesitate to place your comment or question in the comment section below. All right, having discussed the safe ways to follow when disposing solids, let's look at how we can safely dispose liquid waste. Remember, a liquid is defined as anything that flows like water. So some wastes can behave like the water does, flowing, all right, particles sliding over each other. You remember the properties of liquids, all right? Liquid particles are arranged in such a way that they can slide over each other. They can slide over each other like that. And there's minimal spaces between the particles. Of course, the spaces between particles in a liquid is a bit wider than in solids. In solids, particles are tightly packed together so that they are not so free to flow or to move. All right, they are compacted. They just vibrate about fixed positions. But liquid particles slide over each other. So there are some weights that behave like water does. All right, so when you have such weights that you have accumulated, you need again to follow some guidelines on how to dispose them. So raw wastes, raw chemicals such as unused chemicals and the concentrated solutions, these are not by any means are not supposed to be deposited or disposed directly into the sinks in your laboratory at all. All right, so don't dispose these ones directly into the water sinks. So we are saying the following wastes should never be disposed directly into the sinks in the laboratory or into the sewage system. Remember that the sewage systems, some sewage systems lead into small streams of water like rivers, where there are organisms, we call them aquatic organisms. So when some of these wastes which are harmful are drained into such river systems, they will destroy the aquatic life there. So we are saying these should not in any case be drained into sinks, because most water sinks and sewage systems end up into rivers where there are living things. All right, another type of waste which should never be disposed into sinks or into sewage systems is chlorinated hydrocarbons such as chloromethane. Monochloromethane, we have different types of chloromethanes. All right, we have different types of chloromethanes. There is the chloromethane which is called monochloromethane, which has only one chlorine. We have dichloromethane, which has two chlorines, trichloromethane, which has three chlorine atoms, and what we call tetrachloromethane, also called the carbon tetrachloride. These are not supposed to be drained into the sink because they may end up being drained into rivers where they will have damaging effect on aquatic organisms. Chlorofluorocarbons, also in short known as the CFCs, are also not supposed to be drained into the water sinks because they can be drained into rivers where they will destroy life available there. Brominated hydrocarbons, these are hydrocarbons that are reacted with or are mixed with bromine. Remember that bromine by nature is very toxic, highly toxic. So once it is drained into sinks which lead to rivers, may have a damaging effect there. Heavy metals, this is supposed to be heavy metals, only one metal. So heavy metal wastes such as antimony, mercury, and arsenic, these are very, very poisonous. They are highly poisonous chemicals. So they should never be drained into water sinks in the laboratory. So appropriate measures need to be taken as to how they should be treated. Corrosive wastes such as strong acids and strong bases. Strong acids, an example is sulfuric acid, hydrochloric acid, and the nitric acid. These should not be disposed of into water sinks because of their corrosive in nature, corrosiveness. They destroy metals that get in contact with them. So some water sinks have metals, are made up of metals. So once they come in contact with the acids, the metals can be damaged. Bases such as those with a very high pH, like sodium hydroxide, are also highly corrosive, so they should never be disposed of directly into water sinks. So please, for the good of your exam, which is coming shortly, you should know which chemicals or wastes should not be disposed of into water sinks in the laboratory. Why? Because when these are disposed of into the water sinks, some water sinks and the sewage systems lead into rivers. So rivers have organisms in them. We call them aquatic life. So when these are disposed of into rivers, they can have a damaging effect on the organisms that live there. All right, lastly, let's look at steps to follow when disposing gaseous wastes. Maybe it will be appropriate to define a gas. A gas is a form of matter in which particles are spaced far apart, widely far apart, and that the particles move in a random motion. We call that such a substance a gas. So the particles are spaced like that, and they are moving in different directions. Their movement is known as a random motion or Brownian motion. All right, so the gases easily spread in the space where they are found. For example, in the lab, when you carry out experiments that are producing gases, the gases can diffuse very easily in the lab in less than a minute, less than a second. Very quickly, when such a gas is produced in a chemical reaction, it can spread in the room very fast. So if some gases, when they are inhaled, when you inhale them, they can cause problems. They can cause respiratory problems. Some of them are very poisonous. They can even cause fainting in many of you. So we need to handle chemical reactions that produce gases in a very careful manner. All right, so most chemical reactions in the laboratory, as you may have learned, produce gases which may have harmful effects to you and the environment. So what do we do when we are carrying out chemical reactions that produce gases? So when conducting experiments that evolve gases, to evolve means to release, to produce, so that produce gases. We're saying when conducting experiments that evolve gases, do not expose yourself. This is supposed to be do not. This should be do not. So we are saying do not expose yourself or your colleagues to the gases. Don't. Let's suppose that the reaction is taking place in a test tube. You are advised to face the test tube away from you and your colleagues. If you're working in a group, make sure that the test tube, the mouth of the test tube is facing away from you and your friends. So we are saying when conducting experiments that produce gases, do not expose yourself or your colleagues to the gases. So such reactions, therefore, should be carried out in the fume hood, which sucks fumes out into the air. Fume hoods are special cabinets. It's like a box in which you can carry out the chemical reactions. So the boxes, the fume hoods, are connected to the outside environment by use of a pipe. All right, so the gases are removed from the lab through diffusion to the outside of the laboratory. Okay, in so doing, you and your friends are safe. But not all schools can have a fume hood. So where a fume hood is not available, such reactions should be carried out in a well-ventilated room. So in this case, it means that the windows and the doors should be open when carrying out these experiments, so that when gases are released from chemical reactions, they should be allowed to diffuse from the lab to the outside of the lab. So keep windows open, doors open. Don't carry out gas-producing chemical reactions or chemical reactions that produce gases. Don't carry them out in a closed lab. Make sure you open the windows, you open the door, so that as the gases are being released, they should diffuse to the surroundings outside the laboratory. So these are some of the safe ways of disposing chemical wastes, which are in a solid state, in a liquid state, and in a gaseous state. All right. So once again, remember to subscribe, to hit the notification bell, so that as I upload more lessons, you should be notified, and you continue learning. Once again, thank you very much for paying attention. I hope to see you again in lesson number 3. In lesson number 3, we are going to be looking at what is called the scientific investigation, still under the same topic called the experimental techniques. Once again, I've been your teacher, Mr. Pochilola. Once again, I will be glad to meet you again next time. But before I go, I want to leave some work for you to do in your free time. Remember to share with me the answers that you come up with, so that I can also appreciate and, of course, learn from you. Once again, thank you very much for your undivided attention.